In this geometry problem, we're given a rectangle containing two circles. The right-hand circle is the largest circle that will fit inside the rectangle. It's pushed up against the right-hand side so that three sides of the rectangle are tangents to the circle. And on the left, we've got a smaller circle, which is the largest circle that we can fit into the remaining gap. Two sides of the rectangle are tangents to this, and it's just touching the big circle at one point. We've now added in two lines. There is a chord on the larger circle, which goes from the point where the two circles meet up to the top point where the circle meets the rectangle. And we've got a chord on the smaller circle, which again is going from the point where the two circles meet and is going out to the left-hand side where the circle meets the rectangle. What we want to know is, what is theta, the angle between these two lines? To start with, let's label our diagram. I'm going to label the vertices of the rectangle as A, B, C, D. We're going to label the part of the small circle's chord, which touches the rectangle, as E. For the larger circle, where the chord touches the rectangle, is F, and where these two chords meet is going to be G. And we're going to label the centres of the circles as P and Q. We now need to create some angles to see if we can then use these to find theta. So to start with, we're going to look at the smaller circle. I'm going to draw the radii in from P out to E and G. Now, as these are radii, they're the same length, so we've created an isosceles triangle here. So those base angles at E and G are going to be the same. So let's label them alpha. We can do the same thing for the larger circle. So we're going to put the radii in Q, G, and Q to F. They're the same length. So again, we've got an isosceles triangle, and we're going to call these base angles beta. I'm now going to add in a tangent to our two circles where they meet. Now we can see that as PG is a radius, and our red line is a tangent to the circle, and they're meeting on the circumference, this means that they must form a right angle. Now for the larger circle, GQ is also a radius, meeting a tangent on the circumference, so that's also a right angle. Two right angles together make 180 degrees, so we've just shown that PQ is a straight line. Now, as we've got the angles alpha, theta, and beta all going around this straight line at G, we know that theta plus alpha plus beta must equal 180 degrees. I'm going to label this equation 1 because we're going to come back to it later. Now, to solve this problem, we're going to focus on the quadrilateral formed by the points B, F, G, and E, which I've labelled in red on the diagram. Now, looking at the angles of these one by one, we can use the fact that BEP is a radius meeting a tangent, hence it's 90 degrees. So we can write BEG as 90 minus alpha. We can do a similar thing for BFG. BFQ is again a radius meeting a tangent, so BFG is 90 minus beta. As EBF is an angle on the rectangle, we know that that's 90 degrees. And our only other angle left is the theta. All our angles in a quadrilateral must add up to 360 degrees. So we can bring all these together to say that 90 for EBF plus 90 minus alpha plus 90 minus beta plus theta equals 360 degrees. Simplifying this, we get that 270 minus alpha minus beta plus theta is 360 degrees. Subtracting 270 from both sides, we get that theta minus alpha minus beta equals 90. However, we can just rearrange this a little bit, write it with a bracket. This is the same as theta minus the sum of alpha plus beta, which again is equal to 90. Now I'm going to call this one equation 2. Now comparing this to equation 1, we can see that the left-hand sides are very similar. 1 is adding alpha plus beta, 2 is subtracting alpha plus beta. So if we add these two equations together, the alpha plus beta will cancel each other out. So we're going to get that 2 theta is equal to 180 plus 90, which is 270 degrees. Halving this gives us a final answer of theta equals 135 degrees. If you've enjoyed this video, don't forget to subscribe or check out more of my videos by clicking on the links here.